Hello, my name is Christian Eskrit. I am a student at Southern Nazarene University, and my research project is over learning from home with conductometric titrations. My mentor for this project was Dr. Shauna York. So for some background, conductometric titrations are often used for acid-base and precipitation reactions. These can, however, be toxic and dangerous using acids and strong bases. And being mindful of the fact that many students would have to be at home due to COVID-19 and not being able to be in the lab or the classroom. Our goal is to develop a safe and inexpensive lab that could be done at home for students who cannot be in person. And we found that borax and glycerol made for a good combination of reagents. So here in our first figure, we have boric acid and glycerol. This boric acid is a weak acid. And as you can see here, the conductometric titration has a much more obvious endpoint than our other ones will. And this is because we were using a weak acid and borax is not an acid. And so in using this weak acid, we had to extrapolate the data, which is so where these endpoints intersect, where these lines intersect is where our endpoint actually is. And so materials, we use just a basic burette setup in the laboratory, and then figure 4 was done at home at my kitchen table using very basic equipment. We used plastic beakers, pipettes, and graduated cylinders. I also did have my laptop with me, of course, to run Logger Pro for data, and I had a Vernier conductivity probe with me as well. And so down here we have our figure 2, which is our borax with glycerol, a concentrated titration. And you can see the endpoint is much more subtle than the previous one shown above with the boric acid. And although there's still quite a bit of change in slope, it's just because the conductivity is such a large number. And where these trend lines intersect is once again the endpoint. And it's important to note our R-squared values were greater than 0.99. And here we have the same thing, but it's just diluted. And we get very similar results, R-squared values above 0.99. For our methods, we would just use whatever reagents we were using. For the majority of the time, it was borax and glycerol. And we would dissolve them in distilled water, and we would make our diluted glycerol with distilled water as well. And at first, we assumed a 1-to-1 ratio, but it's clear that that actually wasn't the case later. We would run our titrations, and we would try to obtain R-squared values greater than 0.99, and we were able to do so. And once the values were set, you can set these two equations equal to each other, solve for x, and that gives you your stoichiometric endpoint. And here we have figure 4, which was done at home at my kitchen table with the basic equipment. And once again, you get very similar data to the one here done in the actual lab setting. And in fact, the R-squared values are slightly better. For results, the table to the right shows that our stoichiometric endpoint was actually, in fact, not 1-to-1. And this was clear after running trials, and it was shown to be 1-to-4. And this made sense because borax is sodium tetraborate, and it has 4 boron molecules per atom. So that was responsible for the 4-to-1 ratio. And in this table here, you can see this is just our bunch of different titrations. And the main thing to focus on is the mole ratio for each one, and then the average mole ratio, which was close to 1-to-4. And as you can see, with increasing concentration, our accuracy actually got worse. And for our conclusions, while the detection is a lot more obvious for something such as, an acid base, for example, titration, those can be dangerous as acids and bases can be. Using borax and glycerol was much more suitable for a greener reagents and a type of what we call kitchen chemistry, because it could be done at home as I did in my kitchen. And it utilizes the same principles as a titration, and the end goal is to find the stoichiometric endpoint. So you get to figure out the mole ratio. It's unknown before, Instead of figuring out a unknown concentration, you're figuring out an unknown stoichiometric product. And so for my acknowledgements, I'd like to thank the SNU McNair department, my mentor, Dr. Shauna York, and the SNU chemistry department, and my references are down below. Thank you.